Good morning, students. I am Dtft Associate Professor, EC Department. Today I am going to discuss your discrete time Fourier transform topic. So first we are going to see about your discrete time Fourier transform. So we start this as Dtft. So Dtft of a sequence x of n is defined by x of e power j omega. If they given the sequence in x of n format, we are going to convert this x of n into x of e power j omega. The formula for x of e power j omega is summation n is equal to minus infinity to infinity x of n e power minus j omega n. And also the inverse discrete Fourier transform of the sequence is defined by x of n is equal to 1 by 2 pi integral minus pi to pi x of e power j omega in the e power j omega with the e power j omega n with respect to d omega. This is the inverse discrete time Fourier transform. And the discrete Fourier transform is defined as let x of n be the finite duration sequence. The endpoint Dft of x of n is expressed by x of k is equal to, here Dft will be represented with x of k and Dtft will be represented by x of e power j omega. Now x of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi k n divided by capital N, where k varies from 0 to n minus 1. And the corresponding IDFT inverse discrete Fourier transform is x of n is equal to 1 by n summation n is k is equal to 0 to n minus 1 x of k e power plus j 2 pi k n divided by capital N, where n varies from 0 to n minus 1. First, the normal DFT formula, there we have e power minus j 2 pi k n divided by capital N. In inverse discrete Fourier transform, there we have e power plus j 2 pi k n divided by capital N. This is the major difference between your direct DFT and inverse DFT formula. Now we go for the problem. Here the problem is derive the DFT of this data sequence x of n is equal to 1, 1, 2, 2, 3, 3 and compute the corresponding amplitude and phase response. Given x of n is equal to 1, 1, 2, 2, 3, 3. The DFT formula is x of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi k n divided by capital N. First of all, we count the number of samples in the given sequence. So the capital N is equal to 6. Capital N is equal to 6. Here the k varies from 0 to n minus 1. So the k value is 0 to 5. The formula for x of 0 is equal to summation n is equal to 0 to 5 x of n e power 0. First n is equal to k is equal to 0 means e value is 0. So x of summation n is equal to 0 to 5 x of n in the e power 0, the value is sum of all the given input samples. So the sum of all the given input sample value is 12. So x of 0 is equal to 12. Then we go for x of 1. X of 1 is equal to nothing but e power summation n is equal to 0 to 5 x of n e power minus j 2 pi n divided by 6. So the value is summation n is equal to 0 to 5 x of n e power minus j pi n divided by 3. Now we expand our summation formula. So x of 0 e power 0, x of 1 e power minus j pi divided by 3, x of 2 e power minus j 2 pi by 3 plus x of 3 e power minus j 3 pi by 3 and x of 4 e power minus j 4 pi by 3 plus x of 5 e power minus j 5 pi by 3. Now we substitute the e power minus j theta formula. The formula is cos theta minus j sin theta. So according to this formula, we are going to calculate the cos value and sin value. Finally, we get x of 1 is equal to minus 1.5 plus j 2.598. Then we go for calculate the x of 2. X of 2 is equal to summation n is equal to 0 to 5 x of n e power minus j 2 pi 2n by 6. The formula is x of summation n is equal to 0 to 5 x of n e power minus j 2 pi n divided by 3. So the value is 1 plus e power minus j 2 pi by 3 plus e power minus j 4 pi by 3 plus e power minus j 6 pi by 3 plus e power minus j 8 pi by 3 plus e power minus j 10 pi by 3. Here also we are going to substitute e power minus j theta formula. E power minus j theta is equal to cos theta minus j sin theta. We substitute the cos theta value and sin theta value. Accordingly, x of 2 is equal to minus 1.5 plus j 0.866. And then we are going to calculate x of 3 value. Here also the formula is summation k n is equal to 0 to 5 x of n e power minus j 2 by 3 n divided by 6. For substituting the values, we get 1 plus e power minus j pi plus 2 e power minus j 2 pi plus 2 minus e power minus j 3 pi plus 3 plus e power minus j 4 pi plus 3 e power minus j 5 pi. The value is equal for 0, so x of 3 is equal to 0. Then also we are going to calculate x of 4. X of 4 formula is summation n is equal to 0 to 5 x of n e power minus j 2 pi 4 pi divided by 4n by 6. We substitute the values and then we are going to calculate cos theta and minus j sin theta value. Substituting the values, finally we get x of 4 is equal to minus 1.5 minus j 0.866. And finally we are going to calculate x of n value is 5. So x of 5 is equal to summation n is equal to 0 to 5 x of n e power minus j 2 pi 5 n by 6. We expand our summation value. So 1 plus e power minus j 5 pi by 3 plus 2 e power minus j 10 pi by 3 plus 2 e power minus j 15 pi by 3 plus 3 e power minus j 20 pi by 3 plus 3 e power minus j 25 pi by 3. The e power minus j theta value, we already say that cos theta minus j sin theta. So substitute the cos theta and sin theta values, when we get x of 3 0 minus 1.5 minus j 2.538. So the final x of k value is equal to 12 minus 1.5 plus j 2.5898 and then minus 1.5 plus j 0.366 and then we get 0 and then we have the value of minus 1.5 minus j 0.866 and minus 1.5 plus minus j 2.598. So in this problem we easily identify whether the answer is right or not, because we have the complex conjugate portion for each of the given presented values. So according to this we are going to easily conclude that whether the answer is right or not.